In this video number 2, we are going to study the control card of the outdoor unit or condenser in an inverter-type air conditioner. If this topic interests you, stay with us and of course subscribe to our channel. In case you want to start our series from the third, the link to our first episode is currently appearing. Let's remember that in the previous video, we had said that the system we have on the screen is powered by electricity through the evaporator unit. By the way, in the next episode we will see the case when the equipment is supplied with electrical energy by the condensing unit. We must mention that the external card initially receives single-phase line voltage from the indoor unit. Being powered, it is the same external card that is in charge of feeding the compressor with a new voltage of the three-phase type. This three-phase supply voltage can change its value and frequency. For this, the outdoor card reads the values taken by its sensors, and the information brought by the signal cable, which comes from the indoor unit. The functions and components of the outer card, we classify them in 1. Card power supply. This part is undoubtedly the one that attracts the most attention, because it will be in charge of feeding energy to the famous inverter compressor. The main blocks of this power supply are 2. Diode source, B. Choke coil, C. Active power filter, D. Condenser, and inverter module, where the transistors stand out, or electronic power switches of the IGBT type. Here it is important to mention that due to the heat emitted by the components of this part, they are always provided with heat sinks. F. Outputs U, V, and W to feed the compressor. Now we are going to quickly explain how this power supply works. 2. At the input, the alternating voltage supply is changed to a positive wave using a diode bridge. B. The diode bridge is located close to the power stage and usually in contact with the heat sinks. Its mission is to rectify alternating current and convert it into direct current voltage. C. The choke coil keeps the current variation constant and removes the pulsations of the DC current rectifier. F. The active power filter suppresses the high-frequency harmonics generated during rectification and improves the power factor. G. Through the capacitor, the output voltage of the active power filter is converted into a stable DC current. Precisely from this part we can get the sensor supply voltage. H. The inverter module is made up of 6 main transistors, which are fed by the output voltage of the DC module and are prepared to obey the brain of the stage and generate triphasic current. Then the inverter module is responsible for modifying the power supply to the motor through the control strategy called PWM pulse width control. This strategy is based on controlling the activation time of each IGBT transistor. On the other hand, the voltages that we must find between the output points U, V and W will be around between 20 to 210 of alternating current voltage in each of the following 3 measurements. U output with V output, V output with W output, U outlet with W outlet. In the event that one of the measurements presents a different value, we can begin to mistrust the status of the stage. It also stands out in this part, the powerful electrolytic capacitors. Before carrying out any measurement, it is advisable to discharge them, since they tend to remain charged at around 400 volts. This operation can be carried out with a resistor, for example, using a light bulb mounted in a lamp holder with 2 wires, but under no circumstances should the capacitor terminals be crossed, as this can cause the destruction of various electronic components such as transistors, circuits integrated, triacs, others. Now it is time to continue with the other parts of the electronic card of the outdoor unit. 2. Connector for the refrigerant temperature sensor at the compressor discharge, to extend the life of the equipment. 3. Connector for the refrigerant temperature sensor in the compressor suction, to measure superheating. This sensor is very important if the equipment has an electronic expansion valve. 4. Power connector for the inverter compressor with 3-phase current. 5. Connector for power supply and control of the fan motor, of the condenser of the outdoor unit. 6. 4-way valve connector, in case the equipment works in heating mode. 7. Electronic expansion valve connector. 8. Coolant temperature sensor connector at the outlet of the condenser, to measure the subcooling of liquid refrigerant. 9. Connector for the temperature sensor from the outside environment to the room. 10. Power and signal input from the indoor unit. It is the electrical connection point of the entire system. A link to our next episode is currently appearing, but first remember to subscribe to our channel.